Don't you think I tried that?
No, actually I don't.
I did.
Live Austin, sure not.
Yeah.
Are you recording already?
Yeah.
Okay. All right. Okay, so you're going to do one of these next class. Okay. This is called a titration. What I'm going to be reacting is ammonium hydroxide. So what's the symbol for ammonium hydroxide? In fact, I'll write it on this. NH4OH. And I'm going to be reacting that with hydrochloric acid, which is good, HCl. And I should produce
water and NH4Cl.
Very good. Water, H2O, and let's see if I can squeeze this in here, NH4Cl, salt. What kind of reaction is it? According to your solutions test, some of you just learned a neutralization. Okay, good. So true to solution true to titration, solution titration that we've been doing. This I bought from the shops, ammonium hydroxide. It says on the bottle that it is exactly 1 mole per liter solution per raw. So I know the concentration of this. Do you see that big M? It says, maybe not, but you can see it, Brennan. 1.0 big M. That's just a lazy way of scientists writing 1.0 moles per liter. But we get a bit, even my moles per liter gets a bit messy, right? The moles and the per, normally I don't put 2 L's there, I just put 1. So big M is a science way of saying mole per liter. Everybody okay with that? Just a shorthand way. Okay, so I know this bottle says this. I'd like to know, because I made this up myself, I'd like to know what the exact concentration is of that HCl. Do you see how this is already kind of looking like a solution stoichiometry? Okay. So what I'm going to do is I'm going to do a titration, and it'll tell me when I have reacted an exact ratio of 1 to 1 mole, because I'm going to add some indicator to this. Everybody get that? Okay, so this is called a burette. Did you know that already? Have we used a burette? Okay, so a burette measures things from 0 on the top to whatever volume on the bottom. And the purpose of the 0 on the top is because I can see that I've had it come out by 3 mils came out. 10 mils came out. Because I really don't care how much is in this burette, I really care how much came out. So the scale is backwards. Now that sounds really easy, but actually when you're reading the difference between 46 and 45, you have to remember to count, is the 45 above or is the 45 below? So then I go 48, no, what am I saying? I don't remember the numbers anymore. If I go 45.8, that's underneath, that's above the 46. Which feels a bit weird. You have to think about it twice before you do it. Okay, so with a funnel, just to be more exact, and less chance of you spilling, you're going to add your base into your burette. Okay? Oh, bad. Oh, good. Okay. All right, so, but who knows what was reacted in here before? Right? Don't know. So right now, there's probably a reaction happening right now. And those little circles that I zoom in on are right now becoming something else in a different kind of compound. So this is not the exact concentration that I was expecting because some of the circles might be reacting at the moment. And so what I'm going to do is I'm going to sheath the burette. What that means is I've poured in a little bit and I start to do this over a sink. I start to roll it until I've coated the outside. Okay, and I'm just going to roll all the way into the sink. Make sense? And you do that 3 times to get 3 good rinses out. And rinse your tip out too 3 times, which I already have all over the table, so it's handy. I meant to do that, you see. Okay. So then you don't have to fill it up to the 0 either, because all I'm concerned about is how much is coming out. So I can start at 48 and end at 58, and I know that I've had 10 come out. Everybody okay with that? All right, so in here is my base. in here is my acid. Now this is pretty exact actually, this burette. So not only can I measure out exactly how much has come out, but I also, it's to 2 decimal places, which is nice. I don't want to add my volume. Can you see that I'm going to need a volume of acid? So this volume here is coming out of the burette. Okay, so whatever volume that says when I'm finished is the volume that I'm going to use in there. The concentration is what the bottle says. Here I would like to find a concentration. Can everybody see that I'm going to need a volume for here too? Okay, I'm going to need a volume. So V equals, and I'm going to put 10 mils in. I'm going to choose to put 10 mils in here and have 10 mils reacting. If I measure my 10 mils with my graduated cylinder, it won't be 10.00. And I'd really like to have as many decimal places, as many significant digits as I can. So I'm going to use this other fancy new apparatus. Anybody know what that's called? A pipette. You've used them before?
No, you showed us one.
I've showed you before. I thought I had. So pipettes are just really exact measurements. So this on here it says, and they'll each be different, more expensive ones are even more exact, that this is 10 mils plus or minus 0.04. So the worst I can get is 10.04 or 9.96. That's the worst I could be off if I've done it right. So it acts like a turkey baster. You guys seen these turkey basters in your kitchen? Okay, so this is going to suck up, and I'm going to get it to go to the meniscus, and I'm going to let it go, and it's going to drain into my flask. But once again, I don't know what was in here. So I'm going to need, and in fact, actually, I don't know what was in here before, so once again, I'm going to rinse it just to be on the safe side. And how many times do I rinse?
3.
You bet. So suck it up. Be careful not to get it in the bulb, because if you get acid in the bulb, it'll start to, whatever else is in there will corrode. It gets kind of gooky. Okay, and once again, I'm going to go like this. Oh, I forgot to show you. Just a minute. And just rinse it out. Okay, I'll show you what I just did. When you're sucking this up, have you guys ever had like some pop or iced tea where you put your straw at the end and you lift it up and then you drink it out of the bottom of the straw? You know what I'm talking about? That pressure that you've kept when your thumb is on the top, I'm using the exact same principle here. If my thumb is at the top, that liquid will stay in my straw. And as soon as my thumb is gone, the liquid comes out. Do you see that? So I'm going to suck it up. Pretend I've rinsed my 3 times. I'm going to suck it up until I get to the meniscus. Whoop. Now I want to go just past the meniscus a little bit. Okay. I've got it quite firm on the bottom, so I've got something kind of almost holding it in, and I've got my thumb on quite firm. And what I'm going to do is I'm just going to release the seal a little bit to allow some of it to drop, but I'm going to do that by rolling it. And can you see it's going down just ever so slightly? And the more I let my thumb off of the pressure, the faster it'll go. So if I roll, I'm just breaking the seal between the straw, the pipette, and my thumb, and I can eventually get exactly 10 mils by going to the meniscus. And then let go, and just let it drain. And there will be some left in the tip, and that's accounted for. It's called calibrated. So this has been measured to have whatever's left in the tip supposed to be there. So there's no need to take it out. So now I have exactly 10 mils of my acid, and I'm about to find out how much volume it takes of this base in order to react. And then I'll have concentration, a volume, 1-to-1 ratio as I cross the bridge, and a volume, and I'm finding the concentration. Everybody get it? So the math itself is exactly what you were doing yesterday, but the apparatus is far more complicated. If I put a white sheet underneath, I can see. This is phenolphthalein. Do you remember us doing a whole bunch of work on indicators? Right, so phenolphthalein is colorless in an acid and pink in a base. So I'm going to start adding this until I get it to turn pink. Now there's a this is the direction of a hole inside here. So if I turn this tap this way, the hole's pointing straight up and down, and I get a flow. If I point it halfway, the hole will be half open, and I'll get half of a flow. So I can control how much I'm adding. Every single tap works, not every single, most taps, like your garden tap outside, works under the same principle. You turn it, you open a hole inside that you just can't see. This is a little stiff. A little stiff. Okay, there we go. So you can see it turns pink. Did you see that?
Yeah.
Why is it pink right there, but then it disappears?
Gets neutralized.
I forgot to take initial volume. Let's just pretend. So the initial volume was, oh, I don't know, let's go 46. Could you, Michael, because that's not a 4. Looks like my son's 4. Okay, make it a real 4 for me. 46.
I'm not left-handed.
Here.
Oh.
4 acres.
4?
46.00. Good. Got very neat handwriting. All right, so I'm going to open this up. Okay, why is it pink in that little spot right there, but then it disappears? What's the matter, Sabrina? Okay, then answer the question.
Sorry, what was it?
For the 3rd time. Why is it pink here in this spot?
Because it neutralizes.
Phenolphthalein is pink in a base. And what's pooled right there? A base. Until I stir it,
Whoa.
and it's reacted, and it's all, the base is all gone. Right now there's excess acid in here, so it's still colorless. Add some base, it's pink there where the base is pooled, mix it up, the base disappears, and I'm just left with salt water and excess acid. So I'm going to keep going until 1 drop of base, 1 drop of base is going to turn my solution pink. So still excess acid, so still colorless. I can tell I'm getting close. There. And that's your perfect endpoint for a very light colored pink. Okay, so it is like a 1/4 of a drop too basic right now. But that 1/4 of a drop, I'm hoping, is after all my decimal places. Okay, so my final volume, somebody with a marker, Brennan, would you please? My final volume is now 59.2. Let's add another decimal place, shall we, to keep it, so I'm going to have to guess on this decimal place. I'm going to say it's 2.2. Yep. So subtracting those 2 will tell me how much base came out, and therefore then I can put the volume here, and now I've got a concentration times volume, bridge. Does that make sense? Who thinks I did that perfectly? I am human, after all. I know I'm good, but I am human. In fact, do you know how good I am? That's so close to being neutral or basic. If I breathe on it, your carbon dioxide dissolves in there and becomes acidic. And I bet you if I breathed into it, I could get it to become colorless again.